All right, everybody, please give a warm welcome to Chris Anderson, editor of Wired Magazine.
Thank you. So today I'm not going to be talking about my day job. I'm going to be talking about what was once a hobby that has turned into something of an obsession, and basically boils down to open sourcing the military-industrial complex. So what could possibly go wrong? I'm going to I'll just start with basically a little story of how I got here, and then we'll get into the technology, some of the legal and business issues around it, where it's going, what it can do, and then hopefully we'll have time for questions. So let me just dive in. Again, I apologize for the I think the images. I'm told this is out of my control, so we will deal. 5 years ago, my day job is running a magazine website, iPad, and all that. We get lots of products in for review. I also have 5 children, and I really want to get them excited about science and technology, and have consistently failed year after year, possibly because I want them to be excited about science and technology. They're not, or possibly they're just not geeks. I started a site which is now quite large, and a company called Geek Dad, specifically to try to find projects that you can do with kids that are fun for you and fun for them, and sufficiently geeky. But my kids mock me and all my projects. However, 5 years ago, on a Friday, we got, in the office at Wired, we got some products in for review. There was a Lego Mindstorms robotics kit and a radio control airplane. And I thought, okay, this we can do, right? I know my kids are into Lego, and planes are cool, right? So I brought them home, and I said, on Saturday, kids, we're gonna build a robot out of Lego, and on Sunday, we're gonna fly a plane. And they said, cool. So this is Saturday. This is Erin. She was, I think, about 8 at the time, and she opens it up, and the instructions show you how to build a tribot, a little 3-wheeled robot. It's really pretty great. I think it's awesome. This is Daniel. Here he's getting it working, etc. So we spent all morning building this thing. We then programmed it. And if any of you have experience with Lego Mindstorms, by the way, I love Lego Mindstorms. So it's on their advisory board. I think it's a wonderful thing. But if you have any experience with this, you will know the same thing that. Oh, is this doing this to you as well? Okay, no. Anyway, you will see the same thing I did, which is that kids are really hard to impress, especially with robots. So they did this, and after you spend all morning programming it, it will roll up to a wall, and then it'll bounce off and go backwards. And they've seen Transformers. They know what robots are supposed to do. Where are the lasers? Why is it not 3 stories tall? It can't fight? So they were kind of disappointed by that, and I was a little annoyed by how disappointed they were, and the whole beautiful programming language did nothing for them because there were no lasers. So then on day 2, I said, okay, fine, we're gonna fly the plane. So this is what we had, and we took it to the park, and this is what happened. I launched it. It went into a tree, and it wasn't so much the humiliating scene of Dad launching a plane into the tree. It was the absolutely mortifying scene of Dad climbing into the tree afterwards to dislodge it. I had to bribe them with ice cream after that. Anyway, so I was annoyed at them. They confirmed all their suspicions that geeky stuff isn't cool, and I went for a run afterwards. And I thought. I thought about the day, and I thought, the Lego Mindstorms kit came with these awesome sensors. It came with a gyro, accelerometer, magnetometer, a compass sensor, had Bluetooth connection so you could connect it to GPS. It had lots of processing power, and I thought, you know what? You could probably almost fly a plane with that. You could probably almost make an autopilot with the Lego. So I came home, and I said, kids, one last thing, and we're going to sit at the dining room table, and we're going to make a Lego autopilot. And so this is the first one we did that night. You can see it's totally hacked, but those are the sensors, those little sort of square blobby things on the back. And I posted it to Slashdot, Lego UAV, and it went on the front page and got lots of attention. And the kids then kind of lost interest, but I went right down the rabbit hole. So this was our first one. We put it in a plane. And you can see, it was really hard to interface the Lego with the radio control system because I didn't at the time have a way to do it. It's easy now, but at that time it wasn't. So we actually used the Lego motors to move the whole servo back and forth on a little rail. Anyway, it kind of worked. We had a little Lego camera pan tilt assembly on the bottom, and Daniel did the programming, and there it is in the plane. And then the next thing we did is we made it a lot better. This is one that's got a 9 degree of freedom IMU, an inertial measurement unit, with gyros, accelerometers, magnetometer, and a proper RC interface. And at this point, I was really starting to sort of think this could actually happen. So we put this one in a plane, and this one really did fly, and is now in the Lego Museum, actually, in Billund, as the world's first Lego UAV. And I was hooked. The kids lost interest, but I was hooked, and I decided I was going to learn all about this. So I Googled Kalman filter and all this stuff, and decided, obviously, Lego is a great way to start, but turns out not to be the right way to make an autopilot. And I kind of, I went down the rabbit hole and started a site called DIY Drones. And this is what I tend to do. I tend to sort of, be sort of dumb in public. And if I ask dumb questions and to share my learnings in public, it turns out that it's kind of inviting for other people to join me. It's my ignorance about all this was an invitation to others to share their own learning and help teach me, etc. So today, DIY Drones is quite big. You can see the stats right there. But basically, our philosophy is that drones, that in your pocket is basically all the technology you need for a drone. In every one of your pockets, you've got a smartphone, I presume. It's got gyros, it's got accelerometers, it's got GPS, it's got a magnetometer, it's got cameras, it's got processing, it's got wireless, it's got memory, it's got everything you need. With the right cable, you can fly a 747, more or less. And thanks to the economies of scale of the smartphone industry and the Apples and Googles and et cetera, those chips are really, really cheap, like just a few dollars per. And so we've hit that moment where technology that 10 years ago was military, industrial, classified stuff costing tens of thousands of dollars is now in your pockets. This is MEMS technology. It's super cheap. It's super good. It's super accessible. It's easy to use. And we're like, it's time for the hackers to take over. So we started creating autopilots. This is our first. This is one of our first ones. This is ArduPilot Mega. It's based on the Arduino open source computing platform. And basically, we just did a derivative of the Arduino Mega board, and then just did a layer on top that had all the sensors and all the necessary RC interfaces, radio control interfaces, and all that. Our current boards look like this. This is the latest, greatest of the ArduPilot series. It's called 2.5. It does. You don't actually get it as a board. You get it in a little box like this. This costs $199, and basically you take this box and you put it in any vehicle, and it makes it autonomous. It is a magic autonomy box. It does planes. It does helicopters. It does multicopters. It does cars. It does boats. I'm sure it does submarines. We haven't tried yet. But anything that's RC, you just put this in there, and suddenly you've got a drone, fully autonomous, totally programmable, with telemetry, GPS, waypoints, the works, which is pretty cool. And it's 100% open source hardware and software. We just yesterday released our latest version of this, which is PX4. This is done with ETH, the Technical University of Zurich, which is one of the best at unmanned aerial vehicle or drone research. And this one's got an ARM core. It's an M4, 168 megahertz. It's a real serious processing power. Comes with all sorts of shields, including things like optical processing and this. So you maybe heard of the Parrot AR drone. Which is this really cool toy you can buy for $300. Unfortunately, it's not really a drone. We define a drone as capable of full autonomy. In other words, it flies itself. You can take over manual control if you want, but basically it is, you give it a mission. With a point and click, and I'll show you in a minute, you point and click on a mission planner, on a map, you say take off, go to these waypoints, loiter, take pictures, keep the camera at something, etc. So basically you look at the laptop or you just watch the video and the plane flies itself or the aircraft flies itself. That's what we call a drone, in other words, capable of full autonomy. The Parrot AR drone is got fantastic hardware and software, but it's not autonomous. However, we just yesterday released this board which will allow you to replace the closed source electronics of the AR drone, and replace it with our open source PX4 electronics, and make it a fully autonomous vehicle. So you may have heard a lot about these multicopters and quadcopters, and that's kind of the thrust of where a lot of us are going these days. I want to explain a little bit how these things work. You may be wondering why now, and the answer is that quadcopters are basically they're inherently unstable. They can't be flown by humans. You need to basically change the speed of the 4 propellers, and as you'll see later, there can be many more. Change the speed of them about 100 or 200 times a second to keep it stable and also to move forward, left, right, and, up and down, etc. Basically, 2 of the props go one way and 2 of them go the other. And each one of them has a speed controller that can operate very fast. And so basically what you do is when you want to go up, you speed them all up. When you want to go down, you slow them all down. When you want to go to the right, you speed up the one on the right and slow down the one on the left. When you want to yaw, which is sort of like this, you speed up the ones that go counterclockwise and you slow down the ones that go clockwise. And it's just physics, it's just math, but it's a solid state device, which is to say, with the exception of the motors themselves, it has no moving parts, which is really kind of awesome. Hopefully my screen will come back here. Just one second. There we go. You can also, once you see the math, once you understand the math, which is really just speeding up and slowing down props, you can sort of extend it. I hope this is showing. You can extend it to all sorts of other configurations, 6, 8. You can do those kind of V-shaped ones at the bottom are designed to make a very clear view for video. You can see the one at the bottom has 6 in 2 sort of stacks, which is again also to open up a space for the camera. And it's just a matter of kind of speeding up things and slowing down others. It's very good for a computer to do, and creates a fantastic robotics platform for aerial robotics, which is technically hard. Anyway, it can only be done by computers, and until the introduction of these MEMS sensors and fast onboard processors, this wasn't possible. So it's kind of been around for about 10 years, and it's becoming the drone platform of choice because it is so flexible, and you don't have to. You can take off in your backyard or use it even indoors. So this is kind of the way it looks. We have these two big code bases: Arducopter for traditional helicopters and these multicopters, and then RGplane for planes. And then we have a desktop software kind of mission planner. And what you do is you just take this board, you get this board, which comes with no software, and then you take this mission plan, you just click on which one do you want to turn this. Do you want this to turn this into a aircraft autopilot, an airplane autopilot, a quadcopter autopilot, a traditional helicopter autopilot, or even a car autopilot? And you just press the button, and it suddenly is reconfigured to that set of aircraft. So it's kind of a universal autopilot in that respect, and it's all because it's open source code created by a community that's been modified for all these different variants. This is the way mission planning looks. You just point and click in the mission planner and give each waypoint a certain task. It can loiter. It can obviously take off and land. It can change altitude of various sorts. It can keep a camera focused on a point of interest. You can tell it to follow. You can just say, you can click and say, go here in real time. Or you can just carry another device that looks like this that has a GPS module and a little radio device. You've probably heard of XB radios. We have our own open source variant called the 3DR radio, which is half the price and dimension open source. And what you do is you just keep one of these in your back pocket, and you just walk around, and the thing will just follow you. So one of the things we're looking at here is with extreme sports, going to let's say you've got a kite surfer or a windsurfer. You can just when you feel like you're photogenic, you push the button on this thing here, a little button, bing, and the copter will take off from the beach, come out, position itself, 20 feet behind you and 20 feet up, and keep the camera focused on you as you do your thing. Just this kind of robo camera or personal droid. And then when the battery gets low, it'll fly itself home. That's the kind of stuff that you can do with full autonomy. I want to explain a little bit about how we're part of the open source hardware movement. And I want to explain a little bit about how this works. It's kind of complex. What basically we because it's hardware, there has to be a manufacturing component to it. So what manufacturing costs money, and there's real dollars associated with the equipment and the components and all that. So DIY Drones is an open source community that's free, and it creates all the software. So the bits are free and created by volunteers. The atoms, i.e. the physical hardware, is created by a spin-off company that we created called 3D Robotics. And we create sort of generic boards, computing boards, and then the community creates the software that gives them intelligence and useful function. This kind of mix of the two, and you've seen many others. The Arduino project is another example of that. MakerBot is another example. Adafruit, SparkFun, Seed Studios. There's a whole bunch of other open source hardware communities out there, and they all tend to have that same approach. Give away the bits, sell the atoms. Community builds the software, does documentation, does support. A for-profit company does the hardware support and all the kind of customer support around that. And it seems to work pretty well. I'll talk a little bit more about that in a bit. I want to then talk about sort of how we migrated to the point where we're making pretty sophisticated electronics. And this is the cover of Make magazine, which is kind of the Bible of our movement. And last year they featured drones, and the guy on the front is Jordi Munoz. And I want to tell you a little story about how I met him. So when I started DIY Drones, again, I knew nothing, and people were just posting their hacks. They're posting their projects. And this one guy posted this hack by which he flew a helicopter with a Wii controller. On the video, he showed the video, and it was really kind of cool. And he used Arduino as the interface between the two. And I thought this was awesome. And I asked him how it worked. He told I hadn't heard of Arduino before. This was 4 years ago or so. And he told me all about it. I'd been using the basic stamp, which turns out to be wildly inappropriate for these purposes. It doesn't have floating point, among other things. So I was really looking for a new computing platform. And he turned me on to it very early in the project. And so we became part of the Arduino project as a result. And then we started doing these projects. We did a blimp called Blimpduino. We did our first plane. And I said, you know what? We're going to have to actually start a company to make the hardware, because it's not enough to post the files and links to where you can buy components, a DigiKey, etc. You actually have people want, if a soldering iron is involved, you're going to eliminate a lot of the potential users. So we need to take soldering irons out of the equation. We need to do the soldering for them. We need to build a manufacturing company. So let's go in business together. And he said, great, terrific. And I said, okay, so tell me a little something about yourself, Jordi. We never met. And he turned out to be, at the time, 19 years old, was from Tijuana, Mexico, had graduated from high school, but not college, was just in his apartment waiting to get a green card, and was kind of bored, which is why he was doing the helicopter thing. And today, he is the CEO of a multi-million-dollar robotics company. And what I love about this is that he was the perfect person for this job, right? He understood open source hardware, he understood open source software, he understood robotics, he was incredibly smart, and he was, willing to try things and hack in public and share YouTube videos, and charismatic, and turns out he had all sorts of connections into the Mexican engineering world, which turned out to be awesome. But what are the odds that in 10 years ago, when the editor-in-chief of Wired decides to start a drone company, that he'll end up with a Mexican teenager who's never been to college? And the answer is 0 10 years ago, and today it makes perfect sense. And that's what I love about this, is that we largely find the best people find us. And today we have, some of our community members work for Apple by day or Google by day, and they contribute to our projects by night. And we have people from around the world, and we never would have found these people, but they found us because we did it in public, in a community. So this was our first. We started obviously in a dining room table, and then a bedroom, and then a garage, etc., and then a little storage facility. So this was our first factory. And today it looks like this. This is just one of our 2 factories. This is the one in San Diego. We have a parallel factory in Tijuana right now, for reasons I'll talk to you in a minute. But we have more than 50 employees. Again, a multi-million-dollar operation. We're only 2 years old, and this is this is now competing and in many ways disrupting the aerospace industry. By building on open source hardware, by having communities do so much of the R&D, we're able to accelerate the innovation path incredibly fast and build a real business model around open source, because hardware intrinsically has a revenue model attached. You sell things for more than they cost. I'll talk a little bit more about the business model in a second. Just briefly, and this you can get this slide online. It's too much to see right now. But open source hardware is a lot harder than open source software. The formats involving CAD files and printed circuit board files and etc. are complex and often based on proprietary standards. The version control doesn't really know how to do diffs for CAD files and other sort of complex design files. The metadata is just all this stuff that's much more complex than text. The physical properties, what the authoring tools were, the parametric qualities of the data, the electrical qualities, the sources of the components, much more complex than just simple ASCII and code. And the skills needed are just incredibly wide. We need analog electronics, digital electronics, hardware engineering, RF engineering, design, documentation, CAD skills. We need 3D printer skills, CNC skills, aeronautic skills. It goes on and on and on. And it's just we've learned a lot about this world, but we never could have done it had we not done it in public on a community. Our business model is really simple. We, as I say, give away the bits and we sell the atoms. We charge 2.6 times the bill of material, times the underlying cost of the product. And 2.6 is kind of a magic number. It could be 2.4, 2.5, 2.6, but basically it allows 40% margin for us as the manufacturer, and another 40% margin for retailers. And what it also means that it's much, much cheaper than closed source stuff. So an autopilot that the military would sell for $10,000, and even or maybe $50,000, and even any closed source company would sell for $5,000 or $10,000, will sell for somewhere between $100 and $200. And that's because the underlying components cost so little, thanks again to the cell phones and then the economies of scale of the cell phone industry, and we don't charge for intellectual property. And our R&D is largely free because it's done by a community. And that is just an amazing advantage. 2.6 is a healthy business for us, but it's orders of magnitude cheaper than commercial, closed source, and God knows, military technology. And that's incredibly disruptive. When we release our files, we release them in their native design format, and within 7 days, the Chinese have cloned us. We allow them to do this. Our license allows for commercial reuse. How can we be in business when we give our cloners our files and permit them to clone us? And the answer is they can't clone our community. And we innovate really fast, and good luck to them for keeping up. What they don't know is what's coming next. And so they can undercut us by about 30%. So not that much actually, but what they don't know is that we've got another product coming out next week and etc. So they're taking some risk. Also, if you buy from them, you're taking some risk because our community won't support you, and who knows what the quality is. So I think we think that the real kind of secret sauce of open source hardware is the community around the products. The community creates the products, the community supports the products, the community supports the other community members who contributed. And that is hard to clone. That allows open source hardware to be truly open without undermining the business models of those who put up the money to do the manufacturing. We try to get, I say 90% the performance of commercial UAVs at 1% the price. We'd like to get 110% the performance of commercial UAVs at 1% the price, or 0.1% of the price. We're not sure it's even that hard. And again, the innovation model of open source hardware is so fast and so efficient and productive. What takes Lockheed, sometimes 6 years and tens of millions of dollars to develop, we can do in a year for basically essentially $0. Now, it's not as good as theirs. Theirs is definitely better. Theirs is more robust. Theirs is mil-spec. Theirs is tested. Theirs is verified and certified and regression tested. They make better autopilots than we do. But 90%. Is good at 1% the price, and maybe 1/5 the time or 1/6 the time is a really interesting approach. And the point is that the gap is shrinking. There's a whole market out there, which I'll talk about, of like people who would be interested in aerorobotics, but are not in the traditional markets of the military, and that's what we're interested in. Regulation is fascinating. By being open source, we're exempted from a lot of the barriers to entry. This is a highly regulated industry, right? These are flying vehicles. It's got the FAA, it's got the FCC, it's got the State Department, it's got the Department of Commerce, all of these things. This thing right here is, in the rules, the export control rules that were written in the 1970s, these things are qualified as munitions. They're cruise missile controllers. It was interesting that, as is often the case with export control, the rules were written long ago are kind of made a mockery of by technology's advance. When my 9-year-old wrote the code for that Lego autopilot and he posted it online, we later determined he had weaponized Lego. Legally, that was weaponizing Lego, exactly. By the way, that line made it to the front page. As I say, my son is completely unimpressed by all of this. But that particular line made it to the front page of Failblog, and he's really impressed by Failblog. So he had a brief frisson of pleasure there. However, there is an exemption in the export control rules for public domain. And one of the nice things about open source is, and again, it depends a little bit on the kind and the implementation and who did it, et cetera. But the way we do it is, and we have legal ruling on this, or at least legal opinion on this, is qualifies as a public domain exemption. So we're not regulated in the same way. The FAA has rules that will not let you fly drones in the airspace commercially, but you can fly it non-commercially as amateurs. So commercially you have to get what's called a certificate of authorization, which takes like a year, and basically there's a handful of them issued every year. You can't get one. But if you're flying non-commercially and you stay under 400 feet within visual line of sight, so you can basically accomplish that, the gold standard of FAA's airspace control is what's called sense and avoid, the ability to see if there's another aircraft in your airspace and avoid it if necessary to protect people. If you are on the ground, because these aircraft, by the way, micro drone, I'll tell you about this in a second. If you are in this thing, you don't have eyes on board. You may have a video on board, but it's not the same thing. You don't have the same peripheral vision. So you need to be on the ground. You need to be able to see it so that you can do the sense and avoid for it, that it can't do itself. So anyway, the point is we comply with those regs. We stay away from built-up areas, stay away from other people, etc. We comply with that. And as a result, my children can fly drones in the park on weekend, or perhaps other children who are more interested in this than mine, although mine can be bribed with ice cream to do it. So they can fly drones in the park on the weekends, but the university we live next to, Berkeley, can't. The biggest companies in the world can't fly drones. The smallest children in the world can. And I think that's just awesome, because what it suggests is that there is a place in the regulations for amateurs. And amateurs do some of the coolest stuff. For the FCC stuff, because we don't sell directly to end users in blister packs and Walmart, we sell to the developers. We're not responsible for that final FCC verification of RF interference, etc. We do comply with liability stuff, although again, the software is free. No money changes hands. So traditional liability doesn't apply there. For the hardware, it does, and we have liability insurance. As you might imagine, when you're asking an insurance company for liability insurance, you don't use the word flying robot. You said electronics is what we were insured against. We comply with all EPA rules about eliminating lead and that kind of stuff. But basically the point is that one of the biggest barriers to innovation in things like the aerospace industry have been these regulatory barriers. And it's really, if you're a small company and you want to build drones in closed source, you can't. You can't fly, you can't export, you can't do any of that stuff. If, however, you're open source and you want to give away the technology and you want to build, the hardware, commodity hardware that uses software created by the internet, you can. And that's great. What that means is that open source has tunneled through the regulatory barriers, routed around the red tape, and otherwise allowed innovation to flourish and to get this technology out of the hands of the military and into the hands of regular folks. And that's been the real lesson of our experience with the open source hardware movement. It is incredibly disruptive, incredibly transformative, and maybe someday we'll be sued or we'll find out that we're infringing on some patent, and we'll just have to adapt. We'll have to route around it. We'll have to figure out what to do. But so far, so good. It's the best innovation model we've ever seen. This is how we reward our developers. The first time you commit, you get a T-shirt. That is, that's something. It's a physical good, and a commit, it could be just one line, and you get that. Second time, if you do a sustained contribution, you get a coffee mug, T-shirt, and a hardware discount. If you accept a role as a team leader, you get free hardware. If you're a core team leader of one of the key projects, we pay for your travel to the dev meetings once a year. And for the team leaders who shipped a major product, we give them equity in 3D robotics as a company. I don't know whether this has ever been done before, that an open source hardware company has constructed their legal structure so that they can give equity grants or options to volunteer contributors in the open source community. But we think this is the way to go. Thank you. So, you know, now that we've done this a couple years, we think open source hardware is just magical. I mean, it's free and fast R&D. Basically, think of it this way. This is kind of a little gross, a little kind of a crude way to put it, but we ship kind of okay stuff. We ship a board that doesn't have much function and isn't really perfect to the customers. They pay us for the board, then they contribute the code that makes it better. They feed back the suggestions that improve the board, both in the dev teams and the community as a whole. We then incorporate the suggestions. Sometimes they actually ship us, they do the design for us and give us their designs. We then manufacture them and then we sell them back to them again. They do their own customer support. I mean, obviously, we have our own hardware support, but the community, most of the customer support is done by other users, et cetera. So the idea of, and by the way, half of the products we ship, and we now have more than 150 of them, half of these products came from the community themselves. People had ideas, they just made designs, and they just needed someone to put them into production. They give them to us. We then our engineers work with them to make them manufacturable, to ensure they use components efficiently, economically efficient, et cetera. And then we sell them, and then we put them into production, and we sell them to the community at the lowest possible price. And we think this model of community-based development, or co-creation as you call it, is just incredible, and it seems to make everybody, it seems to work for everybody. Things got out there faster, they get out there cheaper. The community's ideas, there's a path for them to show up in the marketplace. And we can outcompete some of the biggest aerospace companies in the world because we have an army of passionate volunteers behind us. As I mentioned, we're exempted from many of the regulatory barriers. The business model, I know the business model of open source software is always a little tricky, but for hardware, it's super easy, right? We sell products for more than they cost. And we're organically profitable on day one. We haven't taken a penny of investment. It's super, there's lots of ways you can go wrong. You get your inventory wrong, you quality assurance wrong, et cetera. But in terms of a business model, it's like head-slappingly obvious. People keep coming, like business professors keep saying, can you explain your business model? And we're like, a 17th century British fishmonger could explain our business model. We sell products for money, and we charge more than it cost us. And they're like, wait, now say that again. It's like, yeah, that's really it. It's just regular business. Now, those products are cheaper to make because of our innovation model. Thank you, open source, software, and all of you, and the generations that have come before us. But the business model is just again head-slappingly easy. And although our products are never perfect, they improve very, very fast, again, because of the with enough eyes, all bugs are shallow phenomenon. And that sort of agreement that the community will help us make the products better, and in exchange, we will get those improvements out fast, is the sort of secret sauce of what we're doing here. So this is really where we're going. This is the drone market out there. Tens of millions of dollars for a Global Hawk, millions for Predators and Reapers, hundreds of thousands of dollars for Scan Eagles. These are all military grade things. Tens of thousands, actually probably hundreds of thousands of dollars for Ravens and Global Hawks and things like that, or sort of the Desert Hawks, or the packages that you see in Afghanistan and beyond. And this is kind of where we're going. Right now, all of our drones cost under $1,000, and there's more than 10,000 of them out there. The military has about 8,000 to 10,000 drones. We have 8,000 to 10,000 in America alone. Globally, we probably have about 20,000 drones. We, the amateurs, have more drones than the military has. Now, ours cost $600, and theirs cost $6 million, and ours are constrained to those FAA regs, and theirs can go anywhere, and ours absolutely are not weaponized, and theirs are. But nevertheless, in terms of getting drones out there, we're doing it. This model is working. We're getting them out. We're democratizing the technology at an incredible rate. So that's where we are right now in the sort of the sub-$1,000 market. We think that the next thing is basically to put this autopilot thing in any radio control vehicle, any air one. This should just be built in, right? I mean, we have this thing called geofencing, where what you do is in that mission plan I showed you, you just define a box, a kind of latitude, just draw a box and give it a floor and a ceiling. So it's a three-dimensional box. And then you turn on geofencing, and now the plane cannot fly out of the box. And then you give your radio control to like a 5-year-old. And what happens? They go woo, bonk, and it hits the virtual floor, and it takes control back away from the 5-year-old, brings it back right to the middle of the box, then gives control back to the 5-year-old. They can't crash the plane, and it won't fly away. And this is I think should just be built into any vehicle. It should of course have this function. We have the intelligence, and we have the technology, we have the GPS, we have the sensors. Why should anyone ever crash again? And there's other variants of it. If you're feeling you're losing control, you just let go of the stick, and the planes then just take over their own control. So we think that sort of tens of dollars, what now costs between like a little less than $200 should cost less than $100, and should be built into any kind of RC unit. And then fundamentally, this is going to be single dollars, and it's going to look like this. This is the smallest quadcopter around. It's actually a commercial one made by the Chinese. This is made by a company called Wakera, but it's hackable. But just the systems integration on this is an example of where we're going to be going. I mean, you've seen swarming quads indoors. Well, that costs. Those things are incredibly expensive. Those a motion capture system, the Vicon system, costs about at least $100,000 and often more. We'd like to open source all of that. The copters, the code, the motion capture, etc. And we want to do it outdoors as well with onboard optical imaging, GPS, RF control, inter aircraft mesh control, etc. We want to open source all of it and make the sky dark with these things. So we're having fun. There are some hard parts in open source hardware. As I say, we need to create this architecture of participation. We need to make it easy, like a great game. It should be easy to pick up but hard to master. Because open source hardware is so complex, and there are these 7 layers of CAD files, and et cetera, all beyond the code itself, it's harder to get the architecture of participation right. But we're making progress. There are many legal questions. No one has told us that what we're doing is 100% legal. We have legal opinion to believe that it is. We have lots of precedent. We talk to the government all the time, but nobody knows, frankly. And in terms of patent, who knows? We may be violating something we don't know. There's just so many patents out there, and when it happens, we'll deal with it. The tools for collaborating are a little limited, and as I say, we deal with piracy all the time. We protect our trademarks, but we don't protect the intellectual property beyond that. And not everybody can compete with the Chinese with the open source model. And who knows? Someday we may find that we can't either. But so far so good. The military and the U.S. government likes what we're doing. The Pentagon has been in touch with us, constantly. We're constantly briefing military agencies. I get a quarterly checkup by the FBI. They're happy so far. We'll see how that goes. The White House, the Office of Science and Technology Policy, has been impressed enough to ask DARPA and the others to use our model for the future military UAVs. And so DARPA, based on the competition model that you saw with the grand challenges, the DARPA Road Race and others, they this year created an open UAV competition called UAV Forge that was built on the DIY drones model. And they just had their first year of competition there, and there's nobody passed passed all the tests, as they didn't with the road race either, but I think they will in the years to come. So the White House wants to use this open innovation model for even military stuff. We don't do military, we won't do military, but we're very happy with people in any sectors using our model to lower the cost of innovation and speed it up. As taxpayers, this is a good thing. But I wanted to end just with one note before I take questions, which is that I think the analogy right here really takes us back about 30 years. When you look at the IBM PC, the first one from the 1980s, you ask, where did that come to be? How did that come to be? Did IBM scale down the mainframe, or did they scale up the homebrew computing club hacker boards? And the answer is yes. This is the first Apple II, but what happened in the late 1970s is just what happened now, which is that the essential technology, in that case it was the CPU, the 8088s and the Zilog chips and those initial processors, became cheap and available and open to all. And suddenly, a technology that had been a military industrial technology, which was computers, which were originally designed for things like artillery shell calculations, became open to anybody. Now, did we know what to do with them initially? No. We just hacked them, we programmed them, etc. But over time, we changed the world. I think the same thing's now happening in the physical world with things like Arduino, Raspberry Pi, with the Moore's Law of sensors that are being driven by your smartphone technology. What you have in your pockets right now is an underutilized hardware platform, those phones. You know this. It can do so much more. We're just scratching the surface of it. And what we're doing is we're just adding the power of open source to all of that. So this is how you can find out more information. DIY Drones is the site, 3D Robotics is the commercial side. Those are my handles, but thank you very much, and I'll take some questions. Thank you. So I think we have microphones here on the sides, and we're also going to have a Q&A session afterwards. So please come up to a microphone. And yes, sir. Thank you.
Though I've seen camera systems integrated into Arduino-based flight systems already, are there plans for 3D Robotics to provide a autonomous camera system?
Autonomous camera system. Yeah, so when you say autonomous camera, we already do camera control. So the drones control the cameras with the pan and the tilts and the zoom, etc. We also offer an optical flow imaging system, so it can do, again, what the Parrot Air drone offers. And that PX4 platform I described earlier, there's a really powerful image processing unit that we'll be releasing quite soon on that, which will do onboard optical and image processing.
Yeah, I'm from North Carolina State University. Participate in the International Aerial Robotics Competition.
Oh, fantastic.
So, just
terrific. Yeah, we're going to open source all of that stuff. Basically, every technology along the chain, we're opening an image. And image processing is the next frontier. Look for the PX4 image board to be out within about a month.
All right. Thank you.
Thank you. I'm going to let's see. Is it just the one mic? It is the one mic. Okay. So yes, sir.
Hi, Chris. Romeo Spagna. I'm actually a community member.
Wonderful
to see you, have you guys come out to DEF CON. So far, everything we've been doing has been with 2.4. Radio hobby RC controllers.
Right.
We've done a little bit of work with the XBs flying over the telemetry link.
Right.
How big is the push going over to flying and controlling these drones over IP? So using flying over IP, Internet Protocol, so an onboard GSM modem or something.
Yeah, so right now we support a couple things. Right, we support, you don't need an RC system, although we do recommend it for safety's sake. You can fly with XB. You can fly with our XB, open source XB versions, which are called the 3DR radios. You can fly with GSM, although the latency is a little too slow for manual. One of the deals with the FAA regs is that you have to be able to take over manual control. That's what the pilot and control and sense and avoid means. So we won't let you fly just with GSM in the United States because you have no way to take over manual control because the latency is too slow for that link. But we do have an Android board called the Phone Drone that will interface with an Android phone or other device. And if you can get the latency down and can fly at home manually, and again, it'll fly itself, so you're really just directing it. That is enabled. So yes, you can fly Android. Yes, you can fly XB. Yes, you can fly 3DR radios. You can pick your frequency, etc. You don't need RC if you don't want it. And every element of that is open source.
Any push for video over IP?
I'm sorry?
Any push for video over IP for the FPV guys?
An open source video radio? No, the Chinese make great ones, and they're analog and they work fine, and it isn't a high priority. They cost $35, $40. Yeah. So it hasn't been a high priority for us.
Thank you.
Thank you. Yes, sir.
I know we probably aren't sure yet, but what are the practical applications of drones? Could you talk a bit about that?
Yeah, that's a good question. The practical applications are initially things basically visual. Aerial photography, aerial videos, search and rescue, border patrol, mapping, a lot of scientific sensing, for example. I mean, the nice thing about drones is you have anywhere, anytime access to the sky. So you can be below the clouds. You can, let's say agriculture, for example. A lot of people are using drones for agriculture. As a farmer, you want an aerial view of your crops, and you might probably want a multispectral view as well. So you can see it in infrared, and you can see the water distribution. You can see how healthy the plants are, and just pick your spectrum, and you'll get it. And then more of the point, you want a daily view. So just putting a drone on a kind of a daily kind of a lawnmower pattern over your land with real-time data is the kind of thing you could never do with satellites. So those are the kind of initial ones. I mentioned kind of extreme sports and kind of the robo video platform, robo camera, or the personal droid. Those are kind of fun as well. But by and large, most of the applications involve visual, video and photography, and a little bit of scientific sensing for now.
Cool.
Yes, sir.
Would you repeat the name of the Chinese quad that you held up?
This one's made by Walkera. It's called a Ladybird.
Would you spell Walkera?
Walkera, Walkera.
Thank you.
Sure.
Hi. I have another question about applications. I'm an RC hobbyist, a geek, and a hacker. And I guess of all the talks at DEFCON, this one scares me the most.
Yeah,
and,
I get that.
I have to ask you, do you feel like you've opened Pandora's box to a dystopian future?
Yeah, I get that a lot. Well, we certainly opened Pandora's box. What future it will bring, we don't know. So yes, we've absolutely taken this technology that used to be military, industrial, classified technology, and we have given it to the world, including the bad guys, I assume. We don't discriminate against anybody. We don't block any countries for software. I mean, actually, our software's on Google Code, and they may block certain countries, North Korea, but we don't. Here's the thing. This technology was already out there. There were back in the day. There were the first of the open source kind of sophisticated open source autopilots was something called Paparazzi, which was started maybe 7 or 8 years ago, and is still around. So there were examples of this before. And to be honest, if my 9-year-old can do it, it's not that complex. It got classified. Obviously this is the most complex Arduino program that's ever been written, so it's not that easy either. But we just don't discriminate. We kind of figure it's a tool. We think that it'll be used more for good than for ill. We do advocate really responsible use, and we don't allow irresponsible use. We don't allow any discussion of weaponization. We actually will call our friends in the government if anyone on our community starts talking about doing something really, really dangerous. And we've done that a few times, and we tell our community that we're going to do that. We warn them ahead of time. But computers can be used for ill and for good, and so we kind of think that it's not our place to judge what people will do. And if we're going to put the technology out there, we want to put it out there in an open context, in an open community, so at least those who are charged with protecting us can see what's going on. And we invite the NSA and the CIA and all the others into our community to watch what's going on, so that they can do their job of being informed about dangers, and we can do our job of promoting innovation.
Cool. Thank you very much.
Thank you.
What do you think the future of the regulations are going to be regarding this? Are you going to be regulated out of business one day?
Yeah, so the answer is the FAA is going through a process to modernize the regulations, and they've got a target of 2015 they'll probably miss. But what they want to do is they want to bring a commercial use of UAVs, make it possible. As I say, right now commercial use in the national airspace is pretty much impossible, and they want to create a de minimis class of, it won't be as this small, but basically ours are typically about sort of this big or maybe that big. They want to make a class of UAVs that are basically not going to bring down a jetliner. They tend to be out of what's called non-friable materials, foam, they're under 2 pounds, etc. And for that class, they'll probably have a lighter regulatory burden, make it easier for commercial use to come in. That's in the United States, and Europe is going through a similar path. As for things like export control, we opened our second production facility in Mexico. And our community is on the internet. The point is that we're not really an American entity at this point. They can shut me down, they can put me in jail, they can bring my 9-year-old in front of Congress for weaponizing Lego. They can shut down our U.S. operations if they want, but the community is global and outside of, I think, any particular country's bounds. And again, our production facilities have now moved, or the main production facilities have moved to Mexico, so we're not even covered by ITAR anymore. So we'll see. We'll see. I know the regulations are going to change, and I'm expecting we may have to fill out some paperwork at some point in the future, especially for people using the UAVs rather than making them. But we feel we're as insulated we are prepared as possible for any regulatory eventuality, so that whatever they do, they won't stop the project, they won't stop the community, and they won't stop the technology. They can stop me, but they can't stop drones.
Got it. Thanks.
Thank you.
Hey, Chris, I'll make this quick. So 20 years ago, radar guns brought radar detectors.
Right.
Obviously, you talk about business, and I'll make this quick. So you have what you have. Now, when am I going to have an in-home drone detector? Because, I mean, if I'm going to have all these 300,000s floating around, what's my distance, what's my carrier, you start manufacturing those as well to guarantee protection? So if we got like 50 million running around my location, I at least know that I'm picking up on at least, a couple of them anyway.
Yeah, I wasn't sure I completely followed the question, but
the radar guns, people started selling radar detectors.
Radar drones.
The detectors started selling that process to protect it in order to counteract it.
Sure, you got basically anybody can use this technology for whatever they want, and I'm sure they'll think of things I haven't thought of. By the way, that'll have to be the last question. Sorry, I will be around afterwards, so you can ask questions to me personally. Yes, absolutely. Occupopters, using drones to look at the military, using drones to turn the cameras back on the police, back on the state. This is absolutely what people are going to do. Being able to looking for traffic spots, I'm sure, is a perfectly good use. The point is that this technology, the military invented the internet, but we figured out what to do with it. The military invented computers, but we figured out what to do with it. The military invented drones, but we're going to figure out what to do with it. And there will be a zillion applications that I have not thought of yet, but the way it's going to happen is by making them cheap, easy, accessible, and ubiquitous, put it in the hands of people with great ideas and let them show us what they can do. Thank you very much.